Hello everyone. In this chapter, I am going to talk about nomenclature. What is the meaning of this term, nomenclature? Nomenclature is a fancy word when we are going to use the concept of naming or writing the formula in the chemistry. Whenever we say nomenclature, we need to expect two types of questions. How to call the formula by their name and how to write the formula of the compounds. In this chapter, we are going to work with this concept, naming and naming rules and writing the formula of the compounds. Before talking about nomenclature, I'm going to remind you in chemistry, we have different types of matters. First, if we are going to remember the matters in the chemistry, we divided them by two different classes, pure substances and mixture. In this chapter, we are going to work on pure substances. Pure substances can be categorized in two types, elements and compounds. Whenever we say elements, we are talking about only one type of atom. One type of atom. We are going to know what does that mean when we say one type of atom. So I'm going to write elements here. So please look at the periodic table. In the periodic table of elements, we have about 118 elements. It means we have 118 atoms. So if I say sodium, I'm talking about sodium only. I don't talk about oxygen, I don't talk about nitrogen and any other elements, only sodium. So if we have only one type of atom, we call that element. In case we are going to have another example, I may say Fe. So this is the chemical formula, chemical symbol of iron. So one type of atom, we call that element. But we just need to know that we have another type of reporting for elements that we call them molecular elements. In molecular elements, we still have the same definition for elements. But look here, O2. Right now, I have two oxygen atoms. Two oxygen atoms. Please look at the definition here. One type of atom. We have only oxygen atom. So this is element. But the difference between this element and this element I wrote here earlier is based on the number of atoms. When we have more than one atom, we call that molecular elements. So when we say molecular elements, we are talking about atoms. We have more than one, but all of them are in one type. In chemistry, we have 7 diatomic molecular elements. 7 diatomic molecular elements. The reason we call them molecules or molecular elements because we combined atoms and atoms joined each other and made molecules. Diatomic, di means two, so we expect to have two atoms, two same atoms, two identical atoms. So these diatomic molecules, let me draw here in this box, H2, hydrogen. Hydrogen always exists in H2. So if I say H, it means I'm talking about hydrogen atom. If I say H2, I am talking about hydrogen molecule. Based on the definition, both hydrogen, either hydrogen atom or hydrogen molecule, they have one type of atom. We call them elements. So elements in the chemistry can be defined in two types: atomic elements, molecular elements. Atomic elements like sodium, we have only one, and if we say molecular elements like H2, we have two hydrogen atoms. So as I said, in chemistry, you just need to know molecular elements: hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. They are 7 diatomic molecular elements in the chemistry. Please memorize them: hydrogen, nitrogen, oxygen, fluorine, chlorine. They are gas molecules. Bromine is liquid and iodine is solid. So at room temperature at 25 degrees Celsius, you may find these 7 molecules in this state of matters. Hydrogen always exists as H2, nitrogen as N2, oxygen in our atmosphere you may find as O2. So this is the meaning of one type of atom when we talk about elements. Right now, I'm going to talk about compounds. We are going to know what is the meaning of compounds. For elements, we have one type of atom, and for compounds, let me say when we have more than one type of atoms. More than one type of atoms. Let me write that one here. So for compounds, we have this definition. If we have more than one type of atoms, I'm talking about atoms, type of atoms, not number of atoms. Please understand, when we say type of atoms, it means we are talking about, for example, Na and Cl. In this example, one atom is sodium, one atom is chlorine. So I'm talking about more than one type of atom. That is why we call that a compound. So each compound composed of at least two types of atoms. This example, NaNO3. In this example, we have one sodium, one nitrogen, and three oxygen. So let me write it here: one Na, one nitrogen, and three oxygen. In general, we may say in this example we have one, two, three types of elements or three types of atoms. So at this time, we say that Na, N, and O combined and made this compound, NaNO3. We have one sodium, we have one nitrogen, and three oxygen atoms or elements here. I prefer to call that elements because we are going to compare compounds and elements. Right now, we are going to work on compounds, more than one type of elements. But before working on them, I may ask you to pay attention and we will find different types of compounds in the chemistry. In chemistry, in general, we are able to categorize compounds in three different classes. First one is ionic compounds. The second one, covalent compounds. And the third major group of compounds, they are acids. So In this chapter, we are going to learn what is the meaning of ionic compounds, how to work on them, and how to call them by their correct formula and name. Same for covalent and acids. Ionic compounds, as we may imply that based on this term ion, they compose of ions, cations, and anions. So if I have a compound composed of ions, cation, anion, I call that ionic compound. One possible question, how to find out we have cation, anion? If you remember that metals make cation and non-metals make anions. So if I'm going to work on one new definition, I may say if we have metal and non-metal, cation, anion, metal and non-metal, it has the same definition, but we prefer to use the first one because it gives us this term, ionic compounds. But to make a simpler definition and maybe better comparison with the covalent and acid, we may write metal and non-metal. So if I have a compound composed of metal and non-metal, I call that ionic compound. Example for that is NaCl. Look here, Na is metal, Cl is non-metal. So metal and non-metal totally make this compound, we call that ionic compound. For covalent compounds, we may use another term as well. So we may call that molecular compounds, molecular compounds, or we may call them molecules. I prefer to call them molecules or molecular compounds because in the next chapter, we are going to work on the covalent bonds. At that time, you have better understanding regarding the covalent compounds. But right now, I'm gonna call them molecules or molecular compounds. When we say molecules or molecular compounds, we just need to remember that if we have non-metal and non-metal, only non-metal in our compound, we call that molecules or covalent compounds. So for the first one, if we had metal and non-metal, cation and anion, so let me write like this, metal and non-metal, like this one. And if we have non-metal, non-metal, like CO2, like CO2. Look, carbon is non-metal, oxygen is non-metal. So it means we have covalent compounds or molecular compound, or in other words, we call that molecules. So the only difference between them is the first part. If we have metal at the beginning, we call that ionic compound. Non-metal at the beginning, we call that covalent compound. How about acids? Acids, they are simplest definition, they have simplest definition in this category. So if we have hydrogen at the beginning of the formula, and after that we have non-metals. So if we have hydrogen at the beginning of the formula, we call it acid. Example for that is like HCl. HCl, let me write like this. This is the example of acids, H at the beginning. Let me correct this definition and say acids always reported by this notation as well, aqueous. Aqueous, it means this compound is water soluble. It means you can dissolve acids in water. So whenever you add acid in water, you are going to make a solution, and we use this notation for that, water soluble. So for acids, we always write like this one, aqueous, H at the beginning and aqueous. So let me summarize this quick definition for ionic, covalent, and acids. When we say ionic compounds, always at the beginning we have metals. If we say covalent compounds, always we have non-metal. And when we have acid, always we have H at the beginning. We never look at the rest of the compounds because everything is same, non-metal. Right now, I'm giving you some examples to see are you able to categorize our ionic compounds, covalent or acid or not. Examples first, I'm going to share with you NaNO3. Look at this compound. At the beginning, I have sodium. Sodium is metal. And after that, we have some elements, all of them, they are non-metals. Non-metals. So it doesn't matter how many types of non-metals. Whenever you look at the first element and you find that this is the metal, metal at the beginning, so you just need to call that ionic compound. Next section, we are going to know why do we have like this many elements here, but here only one element after sodium. So we talk about it a little bit later. This example, H2S aqueous. Look, this compound starts with hydrogen. It doesn't matter how many hydrogen. I said if we have hydrogen at the beginning of the formula. So we call that acid. So this is acid. And this notation expresses we have acids. Another example I'm going to work on that is like this one. N2O5. Nitrogen is nonmetal, so I call that we have covalent or molecules or molecular compounds. Right now, before working on more examples, I'm going to talk about some similarity between these compounds, between these type of compounds. When we say ionic compounds, we said we have cation and anion. When we said covalent compounds, we have again only non-metal, and for acids we have, let me write aqueous here to remind you, we have H and non-metal. As you see here, I am going to keep cation and anion, and in the parentheses let me write metal and non-metal. Cation and anion, it means we have positive ion, and anion means we have negative ion. When we have positive charge, negative charge, example for that is Na1 positive and Cl1 negative. Cation means metals, anion means non-metals, positive, negative. So we have attraction between positive and negative charge, attraction between cation and anion, attraction between metal and non-metals. So this attraction in the chemistry, we prefer to call it ionic bond. So ionic bond means attraction between cation and anion. And in the next chapters, we'll learn that this attraction is coming based on this nature. Electron or electrons are transferred from metals to non-metals. What does that mean? Na makes Na1 plus or Na1 positive and 1 electron. So it means Na sodium atom makes sodium ion and 1 electron. So 1 electron is available here. Cl is going to gain this electron and make Cl1 negative. So this electron will be transferred from sodium to chlorine. So whenever we have this bond, it happens simultaneously because we have available electrons or availability for electrons make cations ready to be in the medium, in the container, in the surface, in the test tube, and anions can gain these electrons and attract these electrons. After that one, they are going to make Cl1 negative, or they are going to make an ion. This negative charge and positive charge attract each other and make this bond, we call that ionic bond. The compound, we have ionic compounds. But whenever we talk about molecules, we don't have any ions. We don't have any electron transfer from one to another one. We have the same type of elements. Both are nonmetals. This one is coming based on sharing electrons. Sharing electrons. So it means each nonmetal is going to share electron or electrons to make a bond. This bond, we call that covalent bond. Covalent bond. So this is another chapter in our course that we are going to work on this. I wanted to give it you what is the difference between ionic compounds and covalent compounds in general. Acids, they are one specific class of ionic compounds because hydrogen is in group number 1, group 1A elements. So it acts like a metal. So metal, non-metal, we are going to call that ionic compounds. But because acids are going to make a main group of compounds in the chemistry, we are going to classify them in a separate group. And in our class, in one chapter, we are going to work on acids as well. Right now, I'm going to ask you, please answer these questions. So let me first, before looking at this, I'm going to ask you, classify each of the following as one of these classes of compounds. Atomic elements, it means we have only one type of atom. Molecular elements, if we say one type of atom, there is a difference between these two. Here we say more than one atoms. We have one type of atoms, but more than one atoms. Let's see what does that mean. Molecular compounds or covalent, ionic compounds, so it's obviously is that. Aluminum, we have only one type of atom, only one type. So we call that atomic element, atomic element. Potassium chloride, KCl, we look at the first part, potassium, so metal, so we have metal, non-metal, so we call that ionic compound, ionic compound. So as you see here, ionic compounds. Here we have Cl2, we have Cl, it repeated twice. One type of atom repeated more than one atom. So we call that molecular elements. C3H6O, this is a formula of acetone. This is one of the commonly used organic solvent in our daily life. So acetone, it starts with C, carbon, non-metal. So whenever we have non-metal at the beginning, you may call that molecular compound. How about this? Carbon monoxide, CO. Carbon monoxide, C, is non-metal, and this one is another non-metal. Non-metal, non-metal, we are going to make another molecular compound or covalent compound, or in general you call it molecule. How about CO, cobalt? This is the only one element because this one belongs to chemical symbol. The reason we have this example, if you have incorrect handwriting, a typo, so you are going to talk about two different compounds. One is carbon monoxide, capital C, capital O, and if you have capital C and lowercase o, you are going to talk about cobalt. Only one atom. One atom, it means we talk about atomic elements. Right now, I'm going to work on some compounds that we may use them in our daily life, and we are going to know what do we call their name by in most commonly used naming. H2O, absolutely you call that water, and we don't write aqueous here, so it's not acid. So H2O is liquid. So for liquid, please remember that water is the commonly used name for H2O. So we don't use the chemical name for H2O like hydrogen monoxide. We don't call that one like this. NH3, this is another commonly used compounds in the chemistry. This is molecular compound because we have nitrogen and hydrogen. We call that ammonia. Ammonia is the formula, this is the name of this formula, NH3. CH4, this is another molecular compounds or covalent compounds. This molecule has this name, methane. Methane is the name of that. How about this one, NaCl? NaCl, it starts with Na sodium, so we call that metal. This is ionic compound. So this compound, we call that table salt. Table salt. Right now, let me write this here. Ionic compounds, in general, we call them salt. We call them salt. Ionic compounds, metals, non-metals, we call them salt. Table salt means only this one, NaCl. The name of this compound is sodium chloride. We are going to work on this naming a little bit later. And finally, C12H22O11. This compound starts with carbon, is non-metal, so we call that covalent compound, molecules or molecular compound. And what do you call this one? We call that table sugar. We have a variety of sugars in the chemistry, different types of carbohydrates. But in our class, we call table sugar as C12H22O11. If you are interested to know more about the sugars and carbohydrates, so you may study the chapters at the end of your textbook. This video is going to remind you some basic, some fundamental definition for nomenclature of compounds. In the next video, I am going to focus on each class of compounds, only ionic compounds, only molecules or covalent compounds, and only acids. Thank you for watching.